Awesome. Oh, that's great. Okay, well, maybe let's get started in the interest of time. Welcome everyone to this session. We're calling it a jam session about geospatial data innovations and some kind of considerations, pros and cons, caveats, advantages, ideas about how best to use these sorts of innovations and new geo tools. So we've got a host of great speakers with us today. We'll be taking turns, each offering some different comments and having some time to interact with questions and ideas in between. I just want to say right off the bat, we are recording this session. Megan, are we currently recording?
Yes, we are currently recording.
Perfect, great. So we will be recording this session. So you can return back and watch it. Please, if you have any concerns about recording, bear that in mind. All right, so let's get started. First off, I'll introduce myself. My name is Marina. I'm on the community team at Mapbox, which is a geospatial technology company. We're a platform company to help you build whatever sorts of location tools or visualizations or maps that your project needs. And we support the application of location tools, geospatial data to important challenges, including disaster risk challenges, disaster risk reduction. We're all about exploring the latest and greatest innovations and new geodata that's out there, but we also recognize the need to support responsible and practical use of these tools, which requires active engagement with communities like you are. So welcome everyone, as well as working with wonderful partners like our guests that we have here today. So over the next hour, we're going to discuss 4 types of data that have powered innovative disaster risk related projects in recent years. So we're going to touch on these sorts of data: crowdsourced data, machine generated or AI generated data, telemetry data, often referred to as mobility or movement data, as well as data generated from models. And the goals of this session, we're going to share information about kind of some of these novel data sources and how they're used. We're going to consider some important questions about when and how to use these data sources, and share insights about projects and techniques of bridging some conventional protocols or kind of government approaches to geospatial data and some of these novel techniques. I've been calling this a jam session, which is, for folks who haven't heard it before, a term that musicians use when they get together and create unscripted music. So we've got 5 talented data scientists and creators here with us who will share their work, but all of you are also part of this jam session. So to create something together, we're going in real time and kind of improvised. We're going to be using a virtual whiteboard, and it's called a Jamboard. So in parallel to this Zoom session, I encourage you to go to this URL, open up another window, and it'll open up the Jamboards. And you can add sticky notes and comments. I'll just show you briefly here to help you get oriented. We can all take a moment and arrive there. So this is where you'll be arriving. I can see folks joining. So everyone, you can add comments using the little sticky note symbol on the side, on the left-hand side there, and move between the boards here. So this is where we'll be collecting questions, thoughts, reactions to the topics, reactions to what the speakers are sharing. So in parallel to the content, feel free to add your ideas here, and then we'll keep coming back to the Jamboard at a few points during the session. All right, so with all that, let's get started with our 4 featured projects, and starting off with an introduction in terms of what they've been working on and what sort of cool geodata they're using. Start things off with Pradeep.
Thank you. Thank you, Marina. Good morning, good afternoon, good evening, ladies and gentlemen. My name is Pradeep Khatioda. I'm the Executive Director at Youth Innovation Lab. I'll be talking today about this platform called Building Information Platform Against Disaster. It is an integrated and comprehensive disaster information management system developed by the government of Nepal with the technical support of my company, the Youth Innovation Lab. Disaster-related data and information is one of the most crucial component of policymaking, planning, and implementing disaster risk reduction and management activities. BIPOT is built at the time when disaster governance in Nepal is changing on the account of federal restructuring of the country. However, disaster data information is still scattered, insufficient, and not fully harmonized. This state in the National Position Paper of 2018 on disaster risk reduction and management by Ministry of Home Affairs, there was a dire need for technological and functional advancement to fully utilize human resources, expertise, experience, and research. On this backdrop, this portal was developed by pooling all credible disaster and spatial data that are available within government domain, non-governmental organizations, academic institutions, and research institutions on a single portal. This platform has 6 modules, as you can see on the screen, which can enhance preparedness and early warning, strengthen disaster communication, strengthen emergency response, enhance coordination post-incident, evidence-based planning, decision-making, and policy-making. Next slide. We are being able to do this with the help of Mapbox. We have used Mapbox style on a lot of modules we have developed. Thanks to OpenStreetMap data, GeoServer, ArcGIS for spatial data visualization. One of the map you can see on the screen has OSM layer overlaid by the flood hazard map layer. This map represents the settlement area inundated by flood hazard. I will get back to you on the next topic. Thank you, Marina.
Thank you, Pradeep. All right, and I think we've got Miho introducing the Urban Risk Lab.
Yeah, hi everybody. Thank you, Marina and Megan, for inviting Aditya and I to join this event. I see some friends in the audience, so thank you for joining us. We're from the Urban Risk Lab at the Massachusetts Institute of Technology, where we develop methods, technologies, and prototypes to embed risk reduction and preparedness into the design of cities to increase community resilience. We're an interdisciplinary team ranging from ethnographers to architects to computer scientists. Next, please. So RiskMap is the first of 2 Mapbox-based projects we'd like to introduce today. RiskMap is a real-time disaster coordination platform for sharing time-critical information between residents and government. It harnesses the power of citizens reporting and social media to map time-critical information without needing to install any new applications or any extra training. And over the past few years, we've been working in several countries with multiple partners. The images to the left show the process we use in asking people to report, while the image on the right is the real-time map used in Japan showing reports after the Typhoon Hagibis last October. Next, please. So Fluxland is the second project we'd like to discuss today. It was developed collaboratively with Fadi Masood and his team at the University of Toronto with support from Broward County in Florida. It's designed to visualize multiple data sets across different scales and problem areas related to climate change and sea level rise. However, it doesn't limit itself to just the visualization of risk and its impacts, but it aims to provide recommendations and actionable insights for its users, and it showcases preparedness strategies and gives design visions for future alternatives. Thank you. I think Aditya will take over in the next portion of the presentation.
Perfect. Thank you, Miho. Thanks for introducing those 2 great projects. And now, Ram, would you like to introduce Thinking Machines?
Sure. Hi, everyone. Ram here from Thinking Machines. So we are a data science consultancy company based off in the Philippines, working with a lot of organizations to help use data science to make better decisions. I primarily work as the Geospatial product lead. So what I do is I focus on a lot of the location intelligence solutions that we build. And we primarily use 2 main data sources to really augment this, which is first is we use a lot of satellite imagery, and from satellite imagery, extracting a lot of information such as building footprints, building classification types, and land use, land cover, which we then use for different use cases depending on the organization's requirements. Just one showcase project that I feel very passionate about. Just a few months ago, we worked with a team in Colombia, wherein they were a humanitarian organization trying to help out Venezuelan refugees who had then migrated to Colombia due to the crisis. Their difficulty was they were having a hard time actually locating where these informal settlements were, and they could not then send out the necessary aid. So what we did was that we actually used satellite images to create probability heat maps across Colombia to locate areas where there are new informal settlements that would then be potentially Venezuelan migrants. This was actually a very successful project where we were able to identify more than 300 new settlements, all validated with partners on the ground. So that's something that we're very happy about. So all the way from the Philippines, working with the Colombian team, it was a very good project for all of us. And more than satellite imagery as well, we overlay this with other external geospatial data, as a lot of the speakers in this call would be using as well. Primarily, I wanted to focus on my personal favorite data set would be mobility data sets. We are Waze partners here in the Philippines. So for example, here, the map in the middle where you see the moving lines, this is the map of the mobility in Metro Manila across the time of COVID, wherein you can see that there's huge decrease in car mobility or car movement across the different quarantine stages that we've had. And we are also Mapbox partners, and Mapbox is also has this cool mobility index as well, where we're able to map out activity in certain areas and be able to use that and to describe what the current situation in certain areas. So here on the right, you also see a map of the changes in mobility in Singapore over the same time frame. So I think we'll discuss more later. But yeah, that's it for me. Thanks, Marina.
Thank you, Ram. And last but not least, Mike from the First Street Foundation.
Thank you, Marina. It's really great to see everybody else's work here already, some commonalities with some of the things that we're doing. My name is Mike Amadeo. I'm Director of Data Science at the First Street Foundation. We are a nonprofit in the United States. We are focused on communicating the risks around climate change. The approach that we've decided to take to this is to really make it hit home with individuals. So we are trying to show how the natural hazard risk is changing because of climate over time, as this relates to people's individual homes. So for us, this is something that there's been a lot of flood modeling out there. There's a lot of flood modeling in the country. However, we're creating a full national data set. It's on the website floodfactor.com. You can go and check it out and search any address in the United States and see the individual properties of flood risk over time, over the next 30 years, and how that's likely to change. And so we're hoping to kind of inspire action that way. And on the next slide, part of what's novel about our model and our approach is that in addition to modeling a very large area, we're able to model at a very fine resolution. So our final hazard layers are at a 3-meter resolution. And that allows us to tie to individual properties and parcels and individual building footprints provided by Mapbox. Associate that with the depth of flooding in our various hazard layers to give specific flooding estimates, depth of flooding estimates at every single property throughout the country. And because we're focused on climate, we're also able to do this at many different layers of probability or different levels of risk, as well as do this across time and across different climate scenarios, so that we can capture climate uncertainty as it moves through time and give every individual a sense of their individual risk. Thank you.
Fantastic. Thanks, Mike. And we're just going to go check and see what's going on with the Jamboards now, see if folks have got some initial reactions. Oh, all right. So this is your invitation to kind of maybe share some thoughts, anything that you're seeing in that first round, jump out to you, something that seems like it would be especially useful. I guess from our speakers, any reactions to what each other have shared, any comments or questions? Sounds like we've got a few in here coming in here. And also it sounds like there's a lot of commonalities between the two, it sounds like. Well, I guess while folks are kind of warming up to, oh, okay, we've got a few things in here. We got OpenStreetMap, shout out to OpenStreetMap, that's wonderful. And Pradeep, you mentioned OpenStreetMap. For folks who haven't heard of that, do you want to just give a quick synopsis of what that sort of crowdsourced data is?
Yeah, definitely. It's been more than 4 years. I'm part of OpenStreetMap team and great fan and contributor of OpenStreetMap. It's a, I would say, to make it more easy, like we use Wikipedia. It's a wiki map where we get crowdsourced information of, like various information like roads, building footprints, like everything we get to see around. It's one of the, I think, a largest platform based on, like people's contribution, like all of you. I think there are more than 60 million contributors so far, and then it's growing. Especially it's being used in special events like 2015 Nepal earthquake, Haiti earthquake, and I think Mapbox is one of the pioneer. We have so a very responsible use of OpenStreetMap data in various products where the government of Nepal and institutions like us, and I think many of us on the panel, we have using those data for various humanitarian purposes. So it's a map by people for people, and like it can be used by anyone.
Thanks, Pradeep. And I see folks joining, that's great. And lots of little sticky notes starting to come in. Maybe just one other comment I'll call on Ram. You mentioned mobility data, and we've got someone who's posted here about telemetry and movement data. For folks who haven't heard of that before, how would you sum that up in a quick soundbite?
Sure. So it really depends on the source. Since this is a Mapbox hosted event, we can talk about the Mapbox telemetry data, wherein whenever you use an application that has a Mapbox app with a location embedded in it, and with a location allowed on your phone, Mapbox is able to get that data and aggregate that information to understand how many people are actually moving around at a, if I'm not mistaken, it's like a 500 meter by 500 meter granularity. So it's not to the level of we know exactly where every person is moving. It's definitely an aggregated data set that just gives us a good idea of where people are going, where activity is happening, which becomes very important during a pandemic, right? Where we can use that to sort of understand where economic activity is going to pick up, or where quarantine is effective and whatnot. There are other sources for mobility data as well. You would another popular one would be Waze data. If you've ever used Waze, wherein they use car information and drive information to be able to predict that. But of course, and we'll be discussing this more a bit later, each of these data sets would have their own biases depending on how it's collected. Yeah, hopefully I answered the question, Marina.
That's perfect. All right, well, this is great. Keep the questions and reactions coming, folks. We're going to go back into our presentation here and keep this going. All right. So the next prompt for our speakers, I was curious about the main limitations or caveats that they would like to add about the sort of geospatial data or tools that they're working with. And so we'll loop back to Pradeep first.
Thank you. So I mean, it's very difficult to let users to know, like what exactly the feature is through a kind of a map. Like people are not used to similar kind of portals, and especially on this map, like let me tell the limitations and how people can like use this kind of feature. This map represents the spatial distribution of total relative seismic risks for all districts in Nepal by combining the probability of fatalities, the median of maximum fatalities, and fatalities with remoteness and SDI. This data can be best used for federal government because all these modelings and like these things were done in federal level, but this cannot be used for decision making in local levels. For example, the municipal government cannot take the reference of this data for decision making in local level in reference to the kind of data on on the map. So most of the time we have found people misinterpreting this data for various decision makings. And analyzing their own situations. So for that, I think we have clearly mentioned here on our metadata sections where people can find the kind of methodology we have used, data sets, facial extent, distribution, distributors informations, and all details are mentioned on this. On next slide. So on this, this was done recently during 2020, monsoon. So one of the very good example of these landslide risks, because recently the monsoon took a lot of human and economic lives. Economic damage of the country. So there are very few government institutions, even in federal level, that can use this kind of tool for decision makings. And it would require a person with sound knowledge of hazard-related disaster risks. In that context, to envision localization of this system and its use for decision making at the municipal level is very challenging. However, it's not impossible. So most of the approach of newly formed National Disaster Management Authority is based on data-driven approach of dissemination of data in various capacities. For example, they have used this daily report of disaster data sets from its social media, from its website, from its emails. And also what they have done is that they have created the awareness videos through which they are sharing about these potential fires, landslide kind of informations through various awareness videos. And then one of the best use of these data sets we have seen is recent COVID-19 situations. When the monsoon was approaching, the government of Nepal used COVID-19 risks data with flood and landslide risks. And they created flood hazard risks with COVID-19, and also landslide risks with COVID-19, and they were able to find the potential hotspot on, what are the combinations of two hazards, and the multi-hazard perspective was very easy to understand. On my next slide, the misinterpretation of return period of flood hazard. People have often tend to misinterpret the frequency of flood hazard. They interpret the 5-year return period as the flood that occurs in next 5 years, which is not right. Instead, it's a flood that occurs every 5 years. So the kind of misspotting is very important, to let people know about, how to use data is very crucial. I'll cover a rest of other things on my next presentation. Thank you, Marina.
That's a really interesting kind of limitation, I guess, or a note that you've found, Pradeep, that so much of this data from OpenStreetMap and other sources is coming from the people, but there's a limit to how much, something that's very technical like this is for the pure public audiences. It seems like it's more for the technical disaster risk managers or government. All right, let's move to our next series of notes about caveats or limitations, and over to Aditya.
Thank you, Marina. And I've already seeing a convergence kind of building with sticky notes and the points that we have. Just to reiterate the kind of initial slides Miho mentioned, we are working with 2 different types of data sets for both the projects. The risk map project deals with much more what we call geospatial data. It is about social networks and how people share real-time information about disasters through those networks. Whereas the other project, flux.land, is much more about government-owned data for long-term climate mitigation. So diving deeper into the first risk map data set, we see first a lot of barriers in a sense to adoption by government. Some of the questions I've already seen on the sticky board is the kind of issues with the trust. who is sort of knowledgeable enough or can send verified information. And our approach to that is also it's much more nuanced, and it is about collecting that data. It is soliciting it and not scraping that data. So you're reaching out to people and asking their consent and their information and integrating them into this process. So it matters how you acquire that data. Secondly, a few caveats is social data tends to be noisy. If you're scraping it, it tends to be more noisy. So it will still need some intervention, either human intervention or through AI to sift out and sort critical requests, especially during disaster time. More and more what we are seeing is the access to internet connected smartphones also tends to skew that data. So essentially it's if areas that don't have such devices, they tend to be much more into informal settlements, they tend to be more vulnerable. So confusing the kind of reporting that you get to the areas that are flooded, 1:1 relationship might be problematic. So our approach has been to work with grassroots organizations, train volunteers in areas that may not have the kind of deeper penetration of these devices, so that we start at least getting some reports early on from those areas. And kind of next set of issues aligned to that is the paradox in social data sets that we keep on seeing, that during disasters there is ton of data. There are tweets, Facebook posts keeps on coming, but there is very little actionable information. So how do we make sure that all of really important actionable information is indexed and can be made available openly to public? So I think that is really the key area that we are trying to push our work into. And then the last part, especially within the risk map project, is working with governments. With that barrier that I initially mentioned, not engaging with social data set also has its pitfalls, and governments lose out on this really valuable on the ground hyperlocal data sets. And also they lose out on an opportunity to intervene to stop rumors or suppress any false information from spreading before it spreads. So that is one more on the social data sets slide. But if you progress to more of flux.land, and the background of this project is on climate change long-term mitigation. Here, as Pradeep said earlier, it's need to convey that kind of scientific models and the uncertainty inherent in them in much more layperson terms, making sure they understand the background of it, and it is changing. There is also a certain temporality to these data sets when we start talking about 30-year, 50-year time horizons. There are some real-time data set, but there are also data sets like land use data that tends to change over 20 years. So you're essentially seeing the snapshot from the past decade. And more importantly, what we are seeing more and more in developing countries is this notion of, it's not always, data poverty is not always about not having data. It is also willingness of the government to share that data and working with them to actually move them and push them to share that data openly with their residents is a key kind of transformation.
I love that framing. That's powerful.
Thank you. And lastly, couple of sort of more caveats that we are seeing is there is also this notion of ambient data that exists. So there are range of data points that cities collect, which we don't see as data in our conventional parlance. So something like building permitting data set, property appraisal data, something like 311 data set, potholes in the street, all of that. The idea is how can we start using some of these ambient data sets much more smartly for parallel usage for something that it hasn't been used before. So that is one of the challenge in front of local governments, is one, how can they use that data, and how can they use that data to kind of push more localized actions and into collective response.
Great, thank you, Aditya. All right, Ram, what kind of caveats do you want people to be aware of with satellite generated data and mobility data?
Sure. Thanks, Marina. And first, I would like to thank you for putting this on top of the agenda. I'm so used to talking about the advantages and promising the world, and then having to manage people's expectations. So this is actually a good start for the discussion. So I kind of separated it into two. The satellite ones, I wanted to focus a bit more on the technical caveats and their limitations, while the external geospatial data, I think, is similar to what a lot of my co-speakers here have already touched upon. So for more satellite AI extracted data sets, the thing about AI is that it's very specific and it learns very specific things, which makes it kind of hard to generalize a lot of the models that you create. So for example, if I create a building footprint detection AI model that extracts footprints from satellite images for the Philippines, that same model will not necessarily work in another country automatically. You would then have to fine tune it and whatnot. Even more so, it also depends on what kind of imagery you're using. So for example, one of the things that we've been wanting to work on since we've started this project is working with the humanitarian open source OpenStreetMap team in the Philippines to supply them with building footprints. But we've sort of had a lot of road bumps because we use a different satellite image than they use. So our building footprints don't match up, right? So the models that you do and make are very specific, and it really takes a lot of time to really contextualize a lot of it and make it usable in a different context. The next two are a bit more on the costs around the technical challenges around satellite imagery, wherein with satellite imagery, the more areas that you want to roll out the model on extract data for, your cost, of course, scales. Cost in terms of the purchasing of the satellite imagery, if you want really high resolution ones, as well as the compute that you would require to be able to run an AI model across an entire country. So just to give you guys an example, we had this one project where we had to run an AI model across the entire Philippines. So that's around 300 square kilometers. So we had to acquire satellite imagery for 300,000 square kilometers. The compute alone to run the AI models was around already $5,000 US. And that was already doing a lot of optimizations using different cloud technologies and whatnot. So you really have to think about, okay, how do we be smarter around where do we apply? Usually nationwide rollouts are quite wasteful. And of course, you would have to have like significant knowledge and understanding of GIS techniques, which I'm sure a lot of the people in this room are already familiar with that. But knowing how to process rasters, knowing how to work with geospatial data is, of course, a requirement for that. Moving now more to the external geospatial data sets. This is something that a lot of people have already touched on, wherein when you, the nice thing about geospatial data is a lot of it is something that you can collect externally, but because you're collecting it from another source, you always have to be mindful about the bias that each data set has. So a while ago, I was talking about the Waze data set and how it supposedly shows you a picture of mobility in whatever area that you're in. However, Waze data is primarily for private vehicles. It doesn't take into consideration people who walk around, people who don't have cars. A lot of public transport don't use Waze as well. So when you start to make policy plans around Waze data alone, you sort of miss out on an entire area, another segment of the community. So usually when it comes to transport, it's about mixing and matching different sets to cover all of these biases. And generally linked to that, right? These biases really, especially if you're working in the disaster reduction space, really makes a difference in terms of who you're capturing with your data set. So for example, if we're unable to capture certain building footprints in an area during, for example, storms in the Philippines, almost every year we have storms that tend to really disrupt infrastructure. And we use building footprints to kind of see the before and after scenario to assess which areas we would want to focus on. If in the before picture you didn't have people there and you didn't have building footprints there, then people would not know that there might be people at risk, right? So when it comes to geospatial data, that kind of incompleteness is really a bigger concern, because you're literally missing out on people that you need to help and you need to service. On the machine learning side also, data completeness is also a bigger concern, whereas you're literally missing out on some areas, right, which your model is not able to learn from them. And I think last is something that we always need to be aware of, is more of the privacy side of things. We like to collect information about like the fact of it being geospatial means you want to collect data everywhere, right? Like location, and we want to understand where people are, and that's what the kind of language that we use. But that's also sometimes kind of intrusive to people's privacy. So whenever we collect data or we get data, we need to understand, is this PII data? How do we aggregate this so this doesn't reveal anything about the people we're collecting about? Usually you don't always need person level data. Aggregated data very much is, you can do a lot with it already. So I think that's just always a good thing to think about whenever we work with geospatial data sets. So yeah, sorry, no pictures, all words, but hopefully it makes sense.
Absolutely, couldn't agree more. And Mike, what warnings do you want attached to the sort of data that you're working with?
Yeah, so I think as Pradeep mentioned a little bit earlier, and Aditya may as well, one big challenge we have is communicating technical information to the general public, to a non-technical audience. We are trying to convey a lot of information, a lot of probability and statistics to, and intentionally, our audience is a non-technical audience. So for us, we spend a lot of time on the user experience of our site so that people can understand what this data really means, what it means to them and how they can use it, and also who they should talk to then learn more. Because for us, this is very much about education and risk awareness. We're not necessarily saying that we have the answers for everything. We can give people some information on what they can do, how they can help themselves, how they can protect their homes, their investments, limit damage in the event that something does happen. But we also want to enable them to work with their local experts to understand on the ground what's actually happening. Because, we're working at a national level. As Pradeep mentioned earlier, some of the national data sets that you have out there may not be exactly what's going on at the local level. So it is extremely important to reach out to local experts and understand what's happening there. The other thing that people don't necessarily understand from the data that we put out is they typically try to compare against the only other flood mapping that they've seen, which is the Federal Emergency Management Agency, FEMA, here in the United States. They put out risk maps that show whether or not you're in the 100-year zone, as Pradeep mentioned. So you've got the 1% annual chance. They don't tell you any more information than that. That just is a guide for whether or not you need insurance. What we try to do is tell you, yes, you might be in the 100-year zone, but you actually have a 50% chance of flooding in any given year, or a 20% chance of flooding. So we're trying to give people a lot more information that way, which can be a lot to digest. So we try to simplify that as well. We do a lot of work around visualization so that they can understand some of the statistics, how that probability kind of compounds over time, because if you're going to be there for 20 or 30 years, that's a lot different from the likelihood that you'll see in 1 year. So like I mentioned, we have a lot of visualizations and things to try to explain probability to non-technical audiences so they can kind of get a better sense of what this data means, and not necessarily compare it against a product that's made for a different purpose. So again, for us, it's really about education and awareness, and also showing how this is changing over time. So because we're looking at climate, there's a lot of uncertainty around the models and how that is going to change over the next 30 years. So capturing uncertainty, like Aditya mentioned, is really super important for us as well, to try to show that there's kind of a range of potential outcomes and not just one specific number. Trying to really educate people to understand all the different facets of this, and that there could be a lot of different things that happen. Just because you have a certain likelihood, you could get any number of outcomes.
Yeah, I love how you invite people in with the sort of relatively simple, here's what's your flood factor score, and then you lead them through a lot more kind of complex education. So wonderful. Let's check in with the Jamboards and see. It sounds like there's been some activity over there. All right. So we've got, speakers, if there's anything in particular that you want to comment on that you're seeing here. We've got some, how do we communicate data uncertainty? We've talked a lot about that. How do we know if something's accurate if people are just reporting it? So maybe that's about the crowd mapping. I know that the MIT team, you were talking about, you're not just scraping any and every data, but you're actively soliciting people for quality data. Let's check in about some of the other concerns.
A little bit about that.
Yeah, please.
So, I mean, to be honest, that's a real question, and frankly, we don't. But I think that's the starting point. So at least in our approach, the way we deal with it is rather than passively scraping Twitter or Facebook, we essentially reach out to people. So if you tweet something, we use the Twitter power track to detect certain trends, hashtag, and essentially reach out and ask you, hey, you said it's flooding, do you want to share a report? Similarly, through other chatbots, we do that. And by that just one act, you create a kind of slight incentive plus barrier that someone has to surmount. So if there is an intention to essentially just create a lot of spam reports, there is a kind of barrier to that. And we use social media networks as a way to make sure that you are who you are, but we don't collect and share that information out to general public. Secondly, there is also more nuanced approach that one can take to this. Crowdsourcing, the word itself seems like we are just scraping whole bunch of data, but there are also shades to that. There can be pro users that are more trusted, government services, whose reports can carry more weight than other reports. So there are ways one can kind of sift through this data differently to build more trustworthiness.
I love that point. Yeah. And we've got some other sticky notes here about quantifying uncertainty, communicating uncertainty. We've got an interesting one here about difficulty having this sort of data widely accepted because of potential inaccuracies, right? Just that concern, that liability. Okay, what if I make a decision based on this data, but it's not complete or it's not accurate? So yeah, well, let's look ahead a little bit to some of the questions about how do we actually go about using this data? What are some of the advantages? And we'll loop back to our presentation. And yeah, keep the Jamboard going. All right. So now we've read the warning labels on these cool sources of data and these cool geospatial tools. Now let's loop back to some of the advantages. Given these limitations, why even use some of this data? Let's kick things off with Pradeep.
Yeah, I mean, I would like to relate with the Jamboard as well. There were a couple of questions regarding like the use of data. That will come on my next slide, but sticking to this slide particularly. So this shows the post-incident data sets of various disasters. So this is posted by the very credible source of information. So in our government terminology, our first responder on government side is the police officers. And they are the one, after any incidents, they go to the field, they collect data, and the data are generated in this kind of form. So this data not just shows the location, but also carries a very, like a lot of information, like the person's name, the number of incidents, infrastructure destroyed, like various forms of economic loss, and a lot of more information. So just a couple of months back during this monsoon, we lost more than 300 lives. And you can see the brown dots. There were so many brown dots you can see around the screen. So those represents landslide and also landslide, right? So so there were incidents in which more than 20 people died, but there are some limitations even using this data as well. For example, these data are reported like after 10 to 15 hours after the incidents, means the response mechanisms has to be really fast, like based on this decision-making system, but which is not happening because of the geographical conditions and so many other things which cannot be understood by this, like simple visualization. On my next slide, I'll show you the blend of open data and also how the response mechanisms is envisioned. So on this, you can see the red dot you can see that represent the fire incident. There is no human causalty, but one infrastructure destroyed. You can see on the left panel. The source is Nepal police, as I mentioned. The date you can see, also the timing. And you can, all these data plotted on this map are from OpenStreetMap data. But what we do not suggest, the practitioners is you can, totally rely on this information. But what this information can be done is like, you can advance this information. You can, for example, on this particular map, you can get the direction, which is linked with a Google map. But you can see the, the distance from the incident to that hospital sub-health post. But the lack of information on this, slide itself is the contact information. So this contact information can be, easily handled by the local authorities. So they can always advance, these kind of capacities and resources of their place, and they can always prepare for better preparedness. What we have done is that we have pulled the information from OpenStreetMap, and once we have credible validation from government side, and then we will synchronize it back to OpenStreetMap for other users. So I think this is something we want to take advantage from open data and also give back to open map communities as well. On my next slide, I'll be focusing on the real-time information. So BPOT portal is the beauty of BPOT portal is it's not a platform where we are generating data. So we are linking various portals which already exist in different domains, but that should be a very credible domains because it's a portal developed by Government of Nepal and hosted by Government of Nepal. So on this map, you can see the information like hydrology, meteorology related informations. They are coming from Department of Hydrology and Meteorology, again, Government of Nepal, and earthquake from Seismology Department, pollution from Ministry of Forest and Environment. We have also linked some of the data from intergovernmental organizations like ICIMOD and also a couple of other organizations. But these real-time informations, help decision makers to know, what's happening where. The beauty of having this portal is the data partnership, because once we have all these data sets linked and visualized in this kind of format, and then people will demand for more credible informations, and there are various instances, through which people can always improve. For example, we have a section called incident report, through which people can report the incident which they seems missing on the reporting side, or there is a feedback form on every information, so they can fill that form and they can always report to the government so that they can improve this data and the quality of data can be ensured. And these data sets can be linked with any regional platform or any global platform, and that can always help for better decision making in regional level as well as in global level. So this is the beauty of having this portal, and I think we can always improve and make a better decision based on these data sets. Over to you now.
I love that cycle you describe of sort of motivating more better data by showing what you can do with the data when it's all brought together. All right, and back to the Urban Risk Lab. What are some advantages of working with this sort of data that you've seen?
So to build on Pradeep's comments as well, we are also really interested in this kind of cyclic nature by showing more data, changing outcomes, getting newer data. And kind of the thematic way, the way we see about or go about doing it, or we phrase our work is connecting this kind of top-down approaches that usually governments have, especially in disaster mitigation space, to more of bottom-up approaches that you see people organizing themselves, working to kind of better their lives. And the tools that we are seeing, open data sets, the kind of interportability of social media based data to geospatial data sets that one can use within Mapbox services. So that enables the kind of seamless transition of these data sets. So what was really important for us working within the RiskMap project is how can we augment the existing emergency management protocols of these government clients, because you definitely don't want to completely change or introduce new systems. So you have to slot in protocols that they are already familiar with. And that can be very easily done through these systems because essentially these are browser-based approaches. Secondly, there is the kind of cross-platform public tool nature of it. And with proper outreach, what we have seen is that these data sets or the kind of level of information that you get is unprecedented. So for example, this report that I've just posted here on top left is from flooding in Chennai, posted on the risk map, is there is an open manhole here underneath this water. Proceed with caution. This level of super local granular data is unforeseen before someone kind of posts it, right? And once we start indexing that data set, pushing that into governance practices, you open up new avenues and new frontiers. Secondly, more on climate change mitigation side, what we are working towards is creating some sort of GIS light approach through browser-based technologies. So as Mike mentioned in his earlier comments, is you have data, but what is really important is what you do with it. Right? So empowering users. In this case, we are working with schools in Broward County to increase awareness and educate students or kids in county about what are the impacts of climate change and sea level rise 30 years down the line. And they can see that on their property, on their locality, and explore different alternatives. So that is possible through these browser-based technologies. And the simplicity of interface, kind of user design that goes with it is also important as well. What we really see in our work is more and more all these policies of mitigation, they're bounded by administrative boundaries, but impacts of disasters, climate change, they're not. So how can one really use this, I would say, epistemological way of looking at zoom in and zoom out of seamless moving through this map and representing data at different scales at different resolution to develop new solutions for such issue is one of the main avenues and one of the main potentials that one can use this technology.
I love that harmony there that you have with Pradeep's point about bringing data sets from across different silos together. All right, thank you. And over to you, Ram. What are you excited about with the data you're working with?
So for me, for the satellite image part specifically, it's being able to collect and get data at scale. And now I wrote here without having to worry about completeness. I had just said a while ago stuff about completeness and bias. So not necessarily without having to worry about completeness, but at least being a bit more sure that you're able to capture a larger area and you're able to capture all the areas necessary and be able to get information from satellite imagery there. Satellite imagery has a wealth of information if you know what kind of info you want to get. So that for me is something that's very exciting. Going more into the external geospatial data, however, I think in a lot of cases, especially here in Southeast Asia, the proxy data sets that we have, though they may have their own biases, tend to be more granular and more frequent or recent than most government statistics. So they may not be perfect, but they do give us a more recent picture. So it's more about understanding, okay, what are the limitations of these, working around these limitations, augmenting it with other data sets. And that's what becomes very important when it comes to geospatial data, which brings me to my third point, wherein working with geospatial data, I think is really, it sounds intimidating, but there's a really low barrier to entry on multiple fronts. On the analysis front, I know a lot of people who are very good geospatial analysts that don't know how to code in Python, just because you have all these existing tools for visualization, such as Mapbox, QGIS, and whatnot. It's very easy to just visualize a map and make a map, right, and share it with whoever. The data sets also are there and readily available. So in a few clicks, you can get access to POI information, population information, administrative boundaries. All of that are available online and readily downloadable for any country that you would want. So, and you could, because they're all location data, it's easier to join these data sets. Whereas if you were in a non-location use case, one of the biggest problems that we have when we don't have location data is how do we merge these two data sets? How does one data set merge with another? But here, as long as you are familiar with the location and the temporality of that data set, it's very easy to put things together and really create a better, like a bigger picture or more holistic picture of like what's happening in a certain area. And last, I think the community is great. The open source community around geospatial is amazing. Like every other week, you just see someone sharing about this cool new data set that was released, someone making this new visualization, someone made this new tool and whatnot. I think in just the past 2 weeks, our team was very much was very happy because there's so many things being released in geospatial in a couple of weeks. If you haven't heard about it, Unfolded, also, if you're not familiar, is a very good tool to visualize and share data sets. UCLA had recently released open source data sets on speed tests, and all of these innovations in this space wherein people are just, I think, predisposed to really being open to what we do and what we share. So it's very easy to get into it and really make connections in the geospatial community. So there.
Thanks, Ram. That's a great note. And so I know we're almost at time, but I want to give the last word over to Mike. But please continue to work in the Jamboards. That'll stay open. You can continue to add more questions and comments and links and resources and that kind of thing. But Mike, what kind of inspiring, encouraging note do you want to end us on?
I think, some of the things that I've heard from the other panelists here have really been spot on. And it's been great to connect with everybody here and see what they're doing. Just speaking a little bit to the data that we're creating and putting out there, we're looking at how this risk is changing over time because of climate change, because of all the sort of computational advances that we're able to build on. We're able to create this data for the entire country in the United States, which is great because, like, as Aditya was mentioning, it doesn't stop at an administrative boundary, which, a lot of analysis happens at the administrative boundary, but not everybody can do all that work. Not everybody throughout the country can, different municipalities can really afford to be doing that. So by creating data sets like this, by everybody here working on things like this, we're able to kind of get at larger solutions, larger approaches, prioritization, because the United States in particular is a little bit behind the curve on dealing with climate change and adaptation mitigation. So to be able to put large amounts of information out there for people to be able to work with large volumes of data is really going to just accelerate our ability to address climate change, to propose solutions, to vet them, to analyze them, and to put them into place sooner rather than later.
That's wonderful. Yeah, so let's keep the jamming going. Let's keep the collaboration going. Here's the contact information for our wonderful speakers today. Thank you everyone who joined. Thank you for your participation in the Jamboards, and look forward to continuing this conversation in future sessions. So thank you, everybody.
Great. Thank you, Marina.
Thank you, everyone. Thank you, Marina.
Thank you, Marina. Thank you, everyone.